In this section, we're going to talk about mental math strategies, and what we mean by mental math is exactly that. We want to be able to come up with strategies that will allow us to solve, for example, 96 plus 167 in our heads. In general, what we are going to, the strategies are going to be based on properties of arithmetic and place value, and we are going to employ a general tactic for most problems. We're going to take a problem that might be difficult to solve mentally, and we're going to turn it into an equivalent problem that is easy to solve mentally. What I mean by an equivalent problem is a problem that has the same answer as the one we're given. So for example, if we're going to try to do this with 96 plus 167, we might go through the following thought process. We might think to ourselves, 96 plus 167 is difficult to solve mentally because it involves regrouping in two place values. The way we could solve that problem is to turn this problem into an equivalent problem in which we wouldn't have to regroup at all. And we can ensure that we won't have to regroup if we were adding by, let's say, 100 as opposed to 96. So if we were to change this number 96 into 100, well, we can't just go around changing numbers into anything we like. We have to compensate by also doing something to 167, which would create, again, an equivalent problem. So the question is, how do we compensate? If we were to change the 96 into 167, what would we, the 96 into 100, what would we have to do to the 167 to obtain an equivalent problem? Well, the associative property of addition can help us here. If we think to ourselves that 96 kind of needs 4 to become 100, it can get that 4 from the 167. So if we think of the 167 as 4 plus 163, the problem as written, 96 plus 167, is equivalent to 96 plus 4 plus 163. The associative property of addition tells us, however, that we can group whichever two numbers we like together. And instead of grouping the 4 with the 163, why don't we just group the 4 with the 96? That is going to create a much easier problem to solve mentally, because of course the 96 plus 4 is 100. So we see through the associative property that 96 plus 167, the problem we were given, which might be difficult to solve mentally, is in fact equivalent, meaning it has the same answer, as the problem 100 plus 163. I think we would all agree that 100 plus 163 is very easy to solve mentally because it involves no regrouping at all. We just have to add in the hundreds place. So that's where our 263 comes from. This is what we mean by a mental math strategy. A strategy that eventually, with practice, we're going to be able to carry out all of these steps in our head. We're not going to have to write this down all the time. As a teacher, though, it's very important to show students all of these steps at the beginning. They get an appreciation for the associative property, and they get kind of a general thought process that they'll be able to apply to more problems. Okay? In fact, we call this process compensation for the following reason. Our mindset was to change the 96 into 100, but then we had to compensate by changing the 167 into 163 to make the problem equivalent. So this is how compensation works for addition. Now there are versions of compensation for the other arithmetic properties as well, so we'll do an example of each. For multiplication, suppose we have the problem 48 times 25. Now the compensation process for multiplication works much the same way it does for addition. We are going to use the associative property of, in this case, multiplication. We might be thinking to ourselves, this problem might be difficult to solve mentally because, again, what process would we use to solve 48 times 25 if we weren't just going to use the standard algorithm? 25 is just not maybe an easy number to multiply by in our heads. However, an easy number to multiply by in our heads is 100. And we can turn this 25 into 100 if we were able to obtain a factor of 4. 25 times 4 is 100. But again, just like with the last problem, we can't just go around turning the number 25 into 100, right? That changes the original problem. We have to compensate by changing the number 48 as well. And the question becomes, how do we compensate? How do we change the 48 to obtain an equivalent problem, a problem that has the same answer as the one we started with? Well, again, we use the associative property. If we think to ourselves that that 25 means a factor of 4, it can get that factor of 4 from 48, because 48 has a factor of 4. So if we think of 48 as 12 times 4, then our original problem of 48 times 25 can be thought of as 12 times 4 times 25. The associative property of multiplication tells us, again, if we want to multiply three numbers together, it does not matter which ones we choose to multiply together first. So instead of grouping that 4 together with the 12 to multiply, why don't we group that 4 together with the 25? If we use the associative property, this problem now becomes 12 times 4 times 25. 4 times 25 we recognize as 100, and through the associative property, we see that 48 times 25 has exactly the same answer as 12 times 100. We would all agree again that 12 times 100 is a very easy problem to solve mentally. It is quite clearly 1200. And again, by writing out all of these steps as a teacher, our students gain an appreciation of the associative property. They get a general feel for the thought process behind something like this. Again, we hope that with practice, these steps become completely mental, that a student looks at 48 times 25 and thinks, okay, I'm going to give a factor of 4 from this 48 to 25 to obtain 12 times 100, which they can also do in their head. That's the idea. So compensation for addition and multiplication works much the same way. Through the commutative properties of addition and multiplication, it does not matter which number we end up choosing to change, the first number or the second number. Our thought process is based on which number is most easily turned into a nice number to work with. In this case, it was 25, because 25 can easily be made into 100 by multiplying by 4. In the previous case, it was the 96, because 96 could easily be made into 100 by adding 4. Now, there are